Hey, what did you guys get for number 65?
I got 21.47.
Oh, really? Okay. That's what I got too. Okay, awesome. Now what's the next problem? Wait, where are the guys?
I don't know, they said they're going to be here like 10 minutes ago.
They're always late.
I know, I'm going to call them up. Jeff, where are you guys? Okay, you guys are coming? Okay, good, okay, bye. They're on their way.
We should totally do like a prank on them. Okay. I have some water balloons. Do you want to get them when they get here? Okay, let's go. Okay.
Water balloons it is. Is Cassandra on lookout?
Yeah, I'm over here. Hi, guys.
Okay, I'm throwing my last balloon.
Perfect.
Now we have them all. Are they there?
Yeah, we're just coming up the stairs. Hurry.
Hide. They're coming. Come, come on.
I'm sorry, we're late.
That was so funny.
Yeah, we totally got them. Here they are.
You guys got
All this for being late?
That was so unnecessary.
Better not be late again.
You could have got the book wet. Tony would be
I know,
pissed.
yes, it's so unnecessary.
You guys got points, and that's all.
Alright, that did hurt a little bit. How much force was in that water balloon?
Let's find out. Okay, let's go. Hey guys, this situation would make a perfect physics problem.
Yeah, it would.
Wouldn't it? Yeah, how would we go about solving it though?
I think I remember from chapter 4 that we had to use Newton's second law, which is force equal ma, to find out the force.
Yeah, but we don't know the acceleration.
Well, let's go measure our variables. Let's measure the balloon and the height so far.
Okay.
Okay.
Okay, that's good. Let's go.
So this is where I threw the balloon from.
Really? Okay, so we have to measure from that distance to where it hit Jeff's chest, which is 376 centimeters.
Okay, let's tape this, the horizontal field.
My crazy grandpa talk about
And we can say stuff right about here.
what he's like with dementia. So it's kind of fun. Every conversation.
Got it? This is where Jeff got hit. So let's use your hand as a target, and I'll time it.
Ready?
Go. 1.11 seconds.
So great, we have everything?
No, we're missing one thing. The mass of the balloon.
Oh, don't worry. I happened to measure it before I threw it off the balcony, and it came out to 300 grams. Good job.
Okay, let's put all our information together now.
Okay.
Okay, in order to start the problem-solving method, we have to draw a free body diagram of the water balloon right before it hits the person. Then we translate this into Newton's second law, which says force equals mass times acceleration, or mass times the change in velocity times the change in time, over the change in time. And from that we can derive mass times the final velocity minus the initial velocity over the change in time. So to find the solution to the problem, we just need to find the initial and final velocity.
Okay, now we put up all of our variables here. We have our mass, which came out to be 0.300 kilograms. Our height is 3.76 meters. Our horizontal distance came out to be 3.18 meters, and our time is 1.11 seconds. And now to solve for our initial velocity. First, we need to separate them into x and y components. Now for our x component, we have our distance of x equals initial velocity of x times time. And then to solve for the initial velocity of x, we have the distance over time. And now for the y component, we have our height equals initial velocity of y times time minus 1/2 gt squared. And now we just put that to solve for initial velocity of y, and we have height plus 1/2 gt squared over t.
Okay, so our next step is to find the final velocity, which we break down into two components, x and y. Assuming that x doesn't have acceleration, we can conclude that the final velocity of x equals the initial velocity of x. Going on to the y, the final velocity of y, we use this equation. Final velocity of y squared equals final velocity of initial velocity of y squared plus 2gh. To solve for it, we would square root it, and we'll get the answer.
Now that we have the two components of initial velocity, we can use these to solve for the initial velocity. By using the Pythagorean theorem, we square root the initial velocity of x squared plus the initial velocity of y squared. We can also do this to solve for the final velocity. We take the square root of the final velocity of x squared plus the final velocity of y squared.
Okay, so now that we have all the number, we can just plug in to solve for VOY, VOX, and then we can figure out the initial velocity from there. So to figure out VOY, we have to use the equation that state the distance plus 1/2 gt squared over t. So our answer came out to be 8.83 meter per second, and our VOX came out to be 2.86 meter per second. And using the Pythagorean theorem that Sarah said, we can conclude that the initial velocity is 9.28 meter per second. To solve for VF, we use the equation VFX equals VOX, and the answer is 2.86 meter per second. And the VF of y is 12.31 meter per second. And using the Pythagorean theorem, we find out that the final velocity is 12.63 meter per second.
Now we can take our initial and final velocities and plug them into our initial equation for the sum of the force equals mass times final velocity minus initial velocity over change in time.
Which was the mass was 0.30 kilograms, and the final velocity was 12.63 minus 9.28 divided by 1.1 seconds.
And the final answer is 0.905 newtons.
Well, that was a great problem, guys.
Way to work as a group.
Okay, but I think we should get back to our studying. I think we got off tangent for a while now.
Okay.
Alright. Oh, by the way, Tim.
I'm Sarah.
I'm Cassandra.
I'm Jeff.
And I'm Tamara.
And we're the Ninja Turtle.
Cowabunga!